this problem. If I just plugged in a 0 right now, I have 1 plus sine of 0 is 0. So 1 plus 0 is 1. Cotangent of 0 as you're approaching from the right, we talked about that yesterday. If you look at your graph, it's the vertical asymptote at 0, so it's going to infinity. So this is 1 to the infinity power. And we can't evaluate that. So what we are going to do is add a natural log into our problem. Okay, so we are going to say the limit Now, the whole reason we add that natural log is because if you go back to your college algebra days, properties of logs, if you have an exponent, that comes down in front. Okay, so at this point, it's like cotangent times my log. Cotangent of 0 is going to infinity times, this is a 1, the natural log of 1 is 0. So now it's like what we did yesterday with the products. If you have infinity times 0, we had to rewrite it as a quotient so that we could do L'Hopital's. If I'm going to drop one of those to the bottom, which one would you rather move? Cotangent. When I put it on the bottom, it would just become tangent. So now the top is still 0 over tangent of 0 is 0. So 0 over 0 means we do L'Hopital's. Okay, it's going to get a little bit ugly here. Derivative of a natural log is 1 over your argument. We have to do chain rule here. Derivative of the inside, derivative of 1 is 0. Derivative of sine is cosine. Angle stays the same, times the derivative of the angle, which is over derivative of tangent. So now there's definitely a lot we could do to clean this up. Let's see if we can evaluate. If we can't evaluate and we're going to have to do L'Hopital's again, then we'll go through all the work to clean it up. Okay. If I just plugged in 0, sine of 0 is, so I have 1 over 1 plus 0. Cosine of 0 is 1 times 4 over secant of 0 is, secant is just a reciprocal of cosine. Cosine of 0 is 1, so the reciprocal will be 1 squared. So we end up with 1 times 4 over 1, which is 4. However, that is not my final answer. We added a log into our problem. We got to the point where we could simplify this. So the final answer, what is the opposite of a log? The e. So our final answer is actually e to the 4th power. Okay, the reason behind that is if you have e to the natural log of, let's say, x, that just gives you an x. What we did is we evaluated this natural log of whatever, that whole function we started with. We got our answer. So our final answer is e to that number. So what you need to remember here, if it's an indeterminate power, you add a natural log, then your final answer will be e to whatever answer you got. Questions there? So this is the only new one we have today. We're just going to practice it. I look at this one. If I just plug in right now, I have 0 to the 0 power. That's an indeterminate form. So what's our strategy? Add a natural log. So we're going to do the natural log of x to the x. If you're worried that you might forget, a lot of times what I do, if I add the natural log, I might go down to the bottom and just write e to a power, so I remember that at the end I have to make e to whatever answer I get. Okay, so with this, my x comes down, so I have x natural log of x. Okay, so 0 times the natural log of 0, we've talked about this one, the natural log graph looks like this, so as you're approaching 0, it's going to negative infinity. And so if we had 0 times infinity, we rewrote it as a quotient. Which one would you rather move to the bottom? The x. If I move it to the bottom, what does it become? 1 over x? Or x to the negative 1, either way. If you move the ln down, it would be 1 over the natural log of x. Okay. So you can write it like this if you prefer the negative 1 power. You could write it like that. That part is completely up to you. Natural log of 0, that's going to infinity. Actually, negative infinity. 1 over x, that's a reciprocal function that is also going to infinity. So we have infinity over infinity, which means L'Hopital's. What's the derivative of natural log x? 1 over x. Over. The derivative of 1 over x, or x to the negative 1, that would become? I'm going to clean that up a bit. Negative x to the negative 2 means negative 1 over x squared. If you flip and multiply, you have 1 over x times negative x squared over 1. So what do we get? Negative x. Can I plug in now? Limit as x approaches 0 of negative x would be 0. So my final answer is e to the 0. And what's anything to the 0 power? 1. Any questions there? What?
We're asking about the 0 to the 0 power. Yes.
What about it?
This class is half over.
So anything to the 0 power is 1 except 0 to the 0 is technically not 1. Alright, let's look at this one. The limit as x approaches infinity of x natural log of x minus 1 over x plus 1.
We did this one this year.
Oh, we did?
Yeah.
Yes, that's right. We did 10 and 11 yesterday, didn't we? Okay, let's go to 12.
We did 12.
Oh, we did not.
We did 11.
I know. That's why I went to 12.
I thought you said let's go to 11 and 12.
I said we did 10 and 11. Let's go to 12. Thank you for trying to be helpful, though. Do appreciate it.
I tried to.
Okay, if I plugged into this one, the square root of infinity squared plus 3 times infinity, what's that going to? Infinity. Minus infinity. So this is like yesterday. This is a difference. Our strategy was to somehow get these into a fraction. So if they were fractions, we would usually get a common denominator. These aren't. What did we do with the radical? This is like over 1. We could multiply by the conjugate. We can multiply by x squared plus 3x plus x on top and bottom. It's kind of been our strategy with radicals all along.
There's a lot of work being done in these problems.
What?
There's a lot of work being done in these problems.
Alright, so if I FOIL on the top, when I multiply those two radicals together, they cancel. Because they're conjugates, the outsides and insides drop, and then negative x times positive x would be a negative x squared. With the denominator. What happens on the top? Alright, so if I look at this, 3 times infinity is infinity. Square root of infinity plus infinity is infinity. So infinity over infinity means L'Hopital's. Derivative of 3x is 3 over. Alright, on the bottom. Keep in mind, the square root is like the 1/2 power. So exponent comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside, plus derivative of x is just 1. Oh, yes, thank you. Alright. I think we're going to have to do a little work before we can just tell what this answer is. If we simplify this. This would be a 2x plus 3 over 2 times the square root of x squared plus 3x. Can't leave a fraction on the bottom, so I'm going to take top and bottom times the 2 radical x squared plus 3x. those denominators would drop. I'd have a 2x plus 3 plus my 2 radical x squared plus 3. Okay. If I plug in, I'm still getting infinity over infinity. So we have two options. We can do L'Hopital's again. Or we can do this one like we've done it in the past. We have done this problem in the past, where we just divided top and bottom by the highest power of x. Okay. The highest x I see is this x squared, but it's under a square root. So that's just x. So if you wanted, you could take top and bottom times 1 over x. And keep in mind 1 over x is the same as 1 over the square root of x squared. So we have 6. In order to bring it under the square root, I have to think of the square root of x squared. So x squared divided by x squared would be 1, plus 3x over x squared would just be a 3 over x. Over, if it's not under the square root, we're just dividing by x. So that would be a 2 plus 3 over x plus 2. Again, I'm under the square root, so I'm bringing in the x squared. So it's been a while since we did those with the radicals, but we have. Then if I plugged in, 3 over infinity is going to 0. Any number over infinity goes to 0. So on the top I get 6. On the bottom we get 4. So 3 over 2 is my final answer. That's a pretty ugly one.
How come you don't divide the 6 for the 2?
I did. I divided the, because they're multiplied. You divide each term, so the things that are added or subtracted. Other questions? Let's do maybe one more. Which one do I want to do? Do you guys have a preference? Let's do example 14. Okay, if I plug in now, I get 0 to tangent of 0 is 0. So 0 over 0, what's our strategy? Add a natural log. If I add the natural log, what do I know I'm going to have to do at the end? An e. Okay. So in adding my natural log, the tangent comes down. Now we have tangent of 0 is 0, natural log of 0 is going to negative infinity, so 0 times infinity means we write it as a quotient. Which one would you prefer to move? Tangent. If you put tangent on the bottom, it becomes cotangent. Okay, now natural log of 0 is going to negative infinity. Cotangent as you approach 0 is going to negative infinity. So infinity over infinity tells me L'Hopital's. Derivative of a natural log is, what's the derivative of cotangent? Okay. If I look at this right now, 1 over 0 is going to infinity. Sine of 0 is 0, so cosecant has an asymptote there, so it's still infinity over infinity. Personally, I don't want to do L'Hopital's again with this mess. Can we clean it up a little bit before we do that? I'm going to try to do 2 steps at once here, so tell me if I lose you. Cosecant is the same as 1 over sine. To divide fractions, we flip and multiply, so this would become a negative sine squared x over 1. Did I lose anybody? So I realized cosecant's 1 over sine, and then to divide, you flip that and multiply. Now this is 0 over 0. So we do L'Hopital's. So the 2 would come down, inside stays the same. Derivative of the inside, derivative of sine is cosine. Over derivative of x is 1. So we have negative 2, sine of 0 is 0, cosine of 0 is 1, over 1, and we get 0. So final answer then would be e to the 0 power, which is 1.
Would it be any different if it was approaching the right side?
No, except the natural log is undefined for negative numbers. So anytime I give you a natural log, we're only going to be approaching from the positive side.
Okay.
Other questions? For tomorrow, I'm giving you odds because I want you to check yourself. They better have work to support your answers. I'm only giving you 4 tonight.